In this video, we are going to be taking a look at the process of electroplating. So electroplating is the process where you deposit a layer of metal onto another object at the cathode of an electrolytic cell. So our diagram here shows a typical electrolytic cell where we have silver at our anode, and then we have a spoon at our cathode. And as this electrolytic cell runs, silver ions are going to be deposited onto the spoon to plate it with a layer of solid silver. So that's how you get silver plated spoons, or you could put a piece of jewelry there, and that is how you get either silver or gold plated or nickel plated jewelry. Okay, so we can do some calculations to figure out how much metal is being plated onto our object. So what I'm showing here is the problem-solving steps or the strategy that you want to use as you're approaching an electroplating question. In the first step, what you're going to do is find the overall charge. And you're going to do that by calculating the charge is equal to the current, which is in amps or coulombs per second, and the time in seconds. So just pay attention to units here. You might need to change them if they're not in the correct units given. Once you've found the overall charge, you're then going to find the number of moles of electrons needed for this charge. And to do that, you're going to use this equation here, where the number of moles of electrons is equal to the charge, which you calculated from this first step here, divided by Faraday's constant, which is given as 96,500 coulombs per mole. Once you figure that out, you're then going to use stoichiometry to figure out the number of moles and the mass that's produced of that particular metal. So let's take a look at an example problem and see how we apply these equations. In this question here, it says an electrolytic cell contains Au3+ or gold 3+ ions. If a current of 26.5 amps is applied to the cell for 310 seconds, how many grams of gold would form on the object acting as the cathode? So let's just highlight a couple of key pieces of information here first. First, we know that we're dealing with gold ions. We know that the current is 26.5 amps and it's applied for 310 seconds. So let's first represent what's going on in this cell. So in this cell, you've got gold 3+ ions that are going to pick up 3 electrons and deposit solid gold onto your object that you're electroplating. Okay, so this is going to be really important to have because we need it for the stoichiometry piece later in our answer. Okay, step 1. We're going to figure out the charge. So we're going to do Q is equal to the current times the time. Taking the values we've got from there, from the question, we've got 26.5 amps and we've got 310 seconds. So that is going to give us a charge of 8,215 coulombs. Step 2, we're going to take that and find the number of moles of electrons by taking the charge and dividing it by Faraday's constant. So that's 8,215 divided by 96,500, which is going to give us 0.08512 moles. Okay. All right. From there, that is the number of moles of electrons. So that is this value here. So now we've got to use stoichiometry and recognize the fact that we got 3 moles of electrons for every 1 mole of gold that we're going to produce, solid gold. So we're going to use the values in here to figure out how many moles of gold that we are going to produce. So that is 0.02837 moles of solid gold. And then finally, in our last step, because we're asked for mass, we're going to do mass is equal to the moles times the molar mass. The molar mass of gold is 196.97, so I'm running out of room here. I'm not going to put in those values. But once we've done that, we're putting in the moles there, and we're putting in our molar mass for gold here. When we round off to significant digits, we get 5.6 grams. So if we applied 26.5 amps for 310 seconds in this electrolytic cell, we would deposit 5.6 grams of gold onto our object.